Something strange has been happening to the beaches across the Caribbean in recent years. Large amounts of a brown seaweed called sargassum have been washing up on shorelines. Normally found in the open ocean, sargassum causes a whole host of issues for coastal ecosystems and communities. So where is this seaweed coming from? Let's find out. Historically, sargassum was found in scattered patches outside its main range. But then something strange happened. In the winter of 2009 to 2010, unusual wind patterns pushed water eastward from the Sargasso Sea towards the Strait of Gibraltar, where a portion was transported southward by the Canary Current along the coast of Africa, delivering a large sargassum population to the tropical Atlantic, where it thrived on nutrients from various sources. This established a new, separate population of the seaweed and gave rise to
the Great Atlantic Sargassum Belt.
That's Roy Armstrong, a professor in the Department of Marine Sciences at the University of Puerto Rico. Roy has been trying to figure out the impacts of sargassum blooms that have been washing up on Caribbean coastlines.
Sargassum is an essential habitat in the open ocean. Think of it as an oasis in the middle of the desert. It provides shelters, for turtles, for many fishes.
Problem is, when fueled by excess nutrients, sargassum can quickly grow and upend the ecology around the islands, which can have negative consequences for nearshore communities and their economies. One of the biggest threats is the pungent and toxic hydrogen sulfide gas that sargassum releases when it decomposes on shorelines. There is so much sargassum that now regularly washes up on the coast that local governments are searching for ways to estimate the size and location of blooms and their trajectories so they can better predict when it will reach the shoreline.
Because we cannot deal with all the sargassum. So what we need is to prioritize. If you can track with satellites a patch that is going to impact a very sensitive area, then you know that that's the highest priority. Now you want to intercept that sargassum before it comes to shore.
Computer models can rewind a clock to see how currents transport water across the Atlantic and help researchers piece together where blooms originate. Additionally, instruments on NASA satellites can detect the signatures of large blooms as they move across the ocean.
The remote sensing technology of NASA is very important, first to detect sargassum and then to track it. And this way, we will have a pretty good idea if a large patch has the potential of coming to the coast and accumulating and therefore impacting the marine ecosystems.
PACE, one of NASA's newest satellites, can add to our growing knowledge of sargassum blooms, further helping researchers decipher this new threat.
Sargassum in general, I don't think it's something that we're going to see go away because that new population is in an area that is perfect for growth. So the issue is how we're going to deal with the sargassum problem. And that's one of the reasons that satellite remote sensing could be very beneficial.
Sargassum continues to threaten coastal communities around the Caribbean, but satellites and instruments can track how and why these blooms occur and help us better safeguard coastal ecosystems and the communities that rely on them.